Hello and welcome to EC&M Asks. This is a Q&A video series where readers pose their most pressing questions and the subject matter experts answer those questions. My name is Ryan Mayfield, founder of Mayfield Renewables. I've been involved in the solar and storage industries for going on 25 years now and very heavily involved in codes and standards, both education and in actually writings of the code. So happy to be here and tackle some of these questions. So the question that came up today, very specifically, was around interconnecting our PV systems and what's lovingly known as the 120% rule in the PV industry. So question is, when I make a solar interconnection to a subpanel, how do I apply the 120% rule? Is it for the subpanel only, or do I have to look upstream to the main as well? And so it's a great question, one that I've seen come up a fair amount. And so for those of you maybe not super familiar, this would put us into Article 705. And so specifically, we're talking about interconnection of multiple sources. And so we're talking about interconnecting, in this case, a PV system with the utility. And we're doing it this would be on the load side of the main service breaker. So we are doing it downstream from the main. And that's an acceptable way. We will be in Article 705.12, and that's the load side source connections. So that's first off where we're going to start. And we're going to then look further into it. And 705.12b is bus bars. These are all 2023 NEC references that I'll give you here. But the rules and applications have been around for many, many years. So really, there's not changes from previous code versions in this case. So the 120% rule, kind of the easiest way to explain it is that our sources of power, the utility, and in this case, a solar system, those are our two sources of power for the bus bar that we're connecting to. Those sources of powers, the sum of those sources of power cannot exceed 120% of the bus bar rating. So what this is telling us is that we can have two sources of power. We can actually exceed the bus bar rating as long as we're following the rules. And the big rule is that the two sources of power have to be at the opposite ends of the bus bar. So if you have a top feed panel that the utility is coming in, then the solar has to be on the bottom, and then vice versa. If it's a bottom feed, then the solar has to come in at the top. So we're just making sure that the sources of power come in at opposite ends, and then that way we don't have any potential of overheating our bus bars. So again, the 120%, it's not really a rule. It's more of a way that we can do it. But it's just the way that it's referred to in the industry. And so when we're doing these calculations, we're going to look at the utility that's coming in, so whatever the utility is being protected at. But on the solar side, what we're going to do is we're going to take the continuous output current of the inverter, and we're going to multiply that by 125%. It's a common code rule for the continuous duty rating. So those are the two values that we're using in our calculations to find this. So I'll go through some examples and we'll kind of talk about it. But back to the question of, can I connect to a subpanel? How do I apply the 120% rule? And so let's just use an example, pretty straightforward example, where you have a 200 amp main panel with a 200 amp breaker, pretty common scenario. And then at the bottom of the main panel, you have a 100 amp breaker feeding a 100 amp subpanel somewhere in the house. All, pretty straightforward stuff. If you want to install the solar in that subpanel, you're going to have to apply, and you want to use this 120% rule, you're going to have to apply it to the panel that you're connecting to, the subpanel in this case. So based on those, the requirements for the 120% rule, what it's telling us is that in the subpanel, we have 100 amps of utilities coming in. The bus bar is 100 amps as well. So 100 amps is the bus bar rating times 1.2 is 120 amps. So the sum of our sources can be 120 amps. 100 amps is already coming from the utility. So we're only left with 20 amps of a PV circuit that we can use. So that would be the limitation. But the other thing that we have to do is we have to go ahead and look upstream of that and make sure that the panel that we are feeding, that the subpanel is being fed from, also meets the 120% rule. So in this case, we have a 20 amp solar breaker, 20 amp solar source that's coming back feeding from the subpanel back to the main. That main is a 200 amp main panel with a 200 amp breaker. So the 200 amp panel means that we have 200 amps times 1.2 That's 240 amps. The utility is taking up 200 of those amps. So we actually have 40 amps. We're only bringing 20 back. All is great. So that's not a big deal. That works perfectly, but we did have to look upstream at there. The other scenario, and this is not completely out of the realm of possibility, I've seen this happen, is where you have a large subpanel downstream. By that, I mean you have that same 200 amp main panel, same 200 amp breaker protecting that panel. So still have that 100 amp breaker going to the subpanel, but for whatever reason, the person who installed that subpanel, they put in a 200 amp panel. It was what was readily available, didn't cost any more, whatever. So now when you apply the 120% rule, you might be thinking, I've got a lot of extra headroom here because you have a 200 amp panel. So the bus bar rate is 200 amps. The 120% rule says you can put 200 amps times 1.2, that 240 amps again. The utility where we're feeding that subpanel, it's only 100 amps. So now I have 100 amps of utility. And so 240 amps minus the 100 from the utility means I have 140 amps of overhead or headroom, if you will, which is great. You can put in a much larger PV system theoretically. So that works well, that you can put in a larger breaker. You could put upwards of 100 amps because that would be the limitation of the feeder to begin with in that panel. But what we have to do is we have to look upstream into that main panel now. So the main panel, again, is 200 amps with a 200 amp main. We've already done that math. That tells us that we get 40 amps of a solar contribution into that main panel. So even though that subpanel is size larger and has that breaker or has a smaller breaker, we're still limited by that upstream panel. So that would be the way, that you have to look at it, and highly suggest that, always looking at it all the way up into the utility connection, because that's going to come into play for your ultimately for your 705.12 connection. So that wraps up that topic. I hope that clears things up for you and answers how you're going to apply subpanels and main panels in the 705.12. So I appreciate your time and look forward to seeing you on the next EC&M Asks.